Welcome to Learn with us. This is the 12th lecture of Basic Electronics.
First, we will have a quick review of our previous lecture. In your last lecture, you understood what is ripple factor. In your previous lecture, you also studied about half-wave rectifier with an RC filter, and you also understood full-wave rectifier with an RC filter. Now, what are the learning objectives of this lecture? In this lecture, you will understand how diode acts as a clamper, and here you will also study about different types of clamper circuits. Now we will understand how diode acts as a clamper. A clamper adds a DC level to an AC voltage. A clamper circuit can be defined as the circuit that consists of a diode, a resistor, and a capacitor, where this capacitor is must. This clamper circuit shifts the waveform to a desired DC level without changing the actual appearance of the applied signal. The important point regarding clamping circuits is that the shape of the waveform will remain same, but its level is shifted either upward or downward. There will be no change in the peak-to-peak or RMS value of the waveform due to the clamping circuit. It means the input waveform and the output waveform will have the same peak-to-peak values. The values of the resistor and capacitor affect the waveform in these clamping circuits. Now, look at this circuit diagram of a clamper, where this is input voltage source and it is connected to a capacitor. This capacitor is further connected to a diode. Now, in parallel to this diode, a resistor is connected, and the voltage drop across this resistor is V0, which is the output voltage. Now, if this is the input signal, for suppose this positive peak is plus Vm and here this negative peak is minus Vm. This is the input signal. Then what is the output signal of this clamper? As I have mentioned in my previous slide, that the shape of the waveform will remain same, but it is either shifted upward or it is shifted downward. Here this point is plus Vm and this point is minus Vm. Now look at this input signal. Here this peak to peak amplitude of this signal is 2 Vm. Now look at this output signal. Here this point is 2 Vm. It means the peak to peak amplitude of this signal is also 2 Vm. Now look at this signal. Here this point is minus 2 Vm. It means the peak to peak amplitude of this signal is also 2 Vm. It means in clamping circuit, the swing of the output waveform is same as the swing of the input signal. There are two types of clamper circuits. First is positive clamper and second is negative clamper. When a DC source is added, then the circuit becomes biased. So now in this case, The types of clamper circuits include positive clamper with positive bias voltage, positive clamper with negative bias voltage, negative clamper with positive bias voltage, and negative clamper with negative bias voltage. Now we will understand the difference between positive and negative clampers. If this input signal is shifted upward, as you can see here, then this kind of clamper is called positive clamper, and if this input signal is shifted downward, as you can see here, then this kind of clamper is called negative clamper. Now look at this example. If you have a clamping circuit like this, where this capacitor is connected to this diode, and here you have a resistor which is connected in parallel to this diode, and if you have output voltage here, and here there is diode voltage, and here you have capacitor voltage, and here there is input voltage. Now if your input signal is a square wave where this point is positive Vi, and for suppose in this case its amplitude is 24 volts, and if this point is negative Vi and its amplitude is minus 24 volts. So how you are going to analyze this circuit? You start your analysis of clamping networks by considering that part of the input signal that will forward bias the diode. So now look at this diode and analyze during which cycle of input this diode will be on. We know that if diode is connected in this direction, then it will conduct during positive half cycle of the input. So during positive half cycle of input, this circuit will look like this, where now this diode is short. Now here you have output voltage, where this terminal is positive, this is negative. We know that this terminal of diode is positive, this is negative. Here you have Vd, and now here this terminal of Vi is positive and this is negative, and we know that current will flow in this direction. So here this terminal of capacitor is positive, this is negative, and here voltage is Vc. I am calling this loop 1. Now if we apply KVL to this loop 1, and if we start from this point, so our KVL equation will be minus Vi plus Vc plus Vd is equal to 0. If diode is ideal, it means Vd is equal to 0. Now this equation becomes Vc is equal to Vi, and we know that Vi is 24 volts. It means here this capacitor voltage is 24 volts. It shows that the current charges the capacitor to the peak value of input voltage, and the capacitor will hold the charge until the diode remains forward biased. So what will be our output here? Now this is our second loop, and if we apply KVL to this loop, our equation will be minus Vd plus V0 is equal to 0. Here V0 will be equal to Vd, and we know that in case of ideal diode Vd is 0, it means output voltage is 0. So what will be our output waveform during positive half cycle of the input, it is 0 volts. Okay, it means that when this diode is forward biased, it will allow electric current to flow through it. Now this current will also flow through this capacitor and it will charge it, and this capacitor will hold this charge until the diode remains forward biased. Now what would happen during negative half cycle of input? Now during negative half cycle, this diode will be off. It means it will be reverse biased. So now this circuit will look like this. Here this open circuit shows that this diode is off and it is not conducting. This is V0, this is Vc. Now this terminal is negative, this is positive, this is Vi. We know that this terminal is positive, this is negative. Okay. Now in this case, this diode does not allow electric current to flow through it. It means the input current directly flows towards the output. Okay. Now here we assume that during this period when the diode is off, the capacitor will hold on to its established voltage level. It means here Vc is equal to 24 volts. Now it means during negative half cycle Vc remains same. Again, if we apply KVL here and if we start from this point, then our equation will be plus Vi plus Vc plus V0 is equal to 0. If we rearrange this equation, we get V0 is equal to minus Vi minus Vc. We know that here Vi is minus 24 and Vc is also minus 24. It means here output voltage is minus 48 volts. Now, in this output waveform, we will draw this output voltage like this. It means the amplitude of this output signal is now minus 48 volts. Now as you can see here, the signal is shifted downward. It means this input signal is now shifted downward. So it is an example of negative clamper circuit. Now here the peak to peak amplitude of this input signal is 48 volts, and in this output waveform this peak to peak amplitude is also 48 volts. Okay, so this is your example of negative clamper circuit. Now look at this example. If you have a circuit like this, where this capacitor is connected to a diode and here this resistor is connected in parallel to this diode. Now voltage drop across this resistor is V0. This terminal is positive, this is negative, this is R. This terminal is positive, this is negative. Here we have VD. Here voltage drop is VC. And if here the input signal is a square wave like this, where this is plus Vi, and for suppose here its amplitude is 24 volts and this is minus Vi and its amplitude is minus 24 volts, then again you will start your analysis by considering that part of input signal that will make this diode on or forward biased. Now we know that if diode is in this direction, it means if diode is connected in opposite direction, then this diode will conduct during negative half cycle. It means during this part of input signal, this diode will be forward biased. So now the circuit will look like this. Okay, where this is R, this is output voltage. Here you have VD, this is positive, this is negative, and now this terminal is negative and this is positive, this is input voltage. Now we know that current will flow in this direction. It means this terminal of capacitor will be positive and this will be negative. So this is VC. Okay, now this is loop 1 and this is loop 2. Now if we apply KVL in loop 1, our equation will be plus VI minus VC minus VD is equal to 0. If this diode is ideal, then VD is equal to 0. It means now this equation will become VC is equal to VI. We know that here VI is 24 volts. It means capacitor voltage is 24 volts now. It means when this diode is forward biased, it will allow current to flow through it. This current will now flow through the capacitor and it will charge it to the peak value of input voltage, which is 24 volts. Now this capacitor will hold this charge until it is forward biased. Okay. Now what will be our output voltage here? Now we apply KVL in loop 2. It means now we have plus VD plus V0 is equal to 0. Now it means V0 is equal to minus VD. We know that here VD is 0 because we assume that this diode is ideal. So here output voltage is 0. So the output waveform during negative half cycle is 0 volts. Now what would happen during positive half cycle? Now diode is connected in this direction. It means during positive half cycle of the input, this diode will be off. Now it means this diode is open and here it is not conducting and no current will flow through it. Okay. Now this terminal is positive and this is negative. We know that this terminal of capacitor is negative, this is positive, and this terminal is positive, this is negative. It means all the input current will now directly flow towards the output. And here this capacitor will retain its established voltage level, which is 24 volts. Okay. Now if we apply KVL in this loop and if we start from this point, our equation is minus VI minus VC plus V0 is equal to 0. It means V0 is equal to VI plus VC is equal to 24 plus 24 is equal to 48 volts. It means during positive half cycle, the output waveform will have the amplitude of 48 volts. So you draw this output waveform like this. It means now this is 48 volts. Okay. Now as you can see here, the signal is shifted upward. It means it is an example of a positive clamper circuit. Now here in this input signal, the amplitude, that is peak to peak amplitude, is 48 volts, and again If you look at here the amplitude of this peak is 48 volts. Okay, so this is an example of positive clamper circuit. Now look at this example. If you have a circuit like this, and here you have a resistor. Now we know that the voltage drop across this resistor is V0, which is output voltage. This is positive and this is negative. Here voltage is Vc, here voltage is Vd, and since this is a DC battery, here voltage is V. For suppose this V is 5 volts. Now we know that from our previous example, if diode is connected in this direction, then this clamper is positive. And we know that here this DC battery is connected. It means now this circuit is biased. And since the positive terminal of this battery is connected to this diode, it means now this circuit is said to be positive clamper with positive bias voltage. Okay. Now if you have an input square wave which is like this, where this is positive Vi, and for suppose in this case it is of 10 volts, and if this is negative Vi, which is minus 20 volts here. So how you are going to start your analysis? Again, you will look at that cycle of input which will make this diode on or forward biased. We know that in case of positive clamper, this diode will conduct during negative half cycle. So we start our analysis from here. During negative half cycle of input, this circuit will look like this. It means now this diode is short, and here you have V0, this is positive, this is negative. Here you have Vd, here you have Vc. And now if, as you can see, we are talking about negative half cycle, and here this amplitude is 20, so this is 20 volts. Now this terminal is negative, this is positive, this is positive, this is negative, this is positive terminal of diode, this is negative. Now what is the direction of current? Current will flow in this direction. So this terminal of Vc is positive and this is negative. Now this is loop 1. Now if we apply KVL to this loop 1, then what would be our KVL equation here? Start from this point. Our equation will be plus Vi minus Vc minus Vd plus V, because we know that this is V is equal to 0. If this diode is ideal, then Vd is 0. Now if we rearrange this equation, we get Vc is equal to Vi plus V. Now we know that this Vi here is 20 and V is 5. So your capacitor voltage is 25 volts. It means when this diode is forward biased, it will allow electric current to flow through it. This current will also flow through this capacitor and it will charge it up to this voltage level. Okay. Now what about V0? For V0, we look at this loop 2 and apply KVL here. So now in this case, we also have V and we start from this point. So our equation is minus V plus Vd plus V naught is equal to 0. And in case of ideal diode, this VD is 0. So now here output voltage is V and V is 5. So it is 5 volts. Okay. So your output waveform is like this. Now we know that during negative half cycle, you have an output of 5 volts. Okay. Now this point is 5 volts. Now, what would happen during positive half cycle of input? During this positive half cycle, the circuit will look like this, where now this diode is open, this is positive, this is negative, and here we have a resistor. Okay, here voltage is V0 plus minus. We know that this terminal of VC is positive, this is negative. And now here this terminal is positive, this is negative, and we know that the positive amplitude is 10 volts, so it is 10 volts. Okay, now the current will not flow through this diode because now it is not conducting and it is off. So this input current will directly flow towards this output. So now if we write our KVL equation here, we start from this point. It is minus VI minus VC plus V naught is equal to 0. So V naught will be VI plus VC, and again here this capacitor will retain its voltage, which is 25 volts. It means here this V naught will be 10 plus 25 is equal to 35 volts. So this is the output voltage during positive half cycle. So how you are going to draw this waveform? It is drawn something like this. And here I don't have enough space. It means this amplitude is 35 volts. Okay. And if I draw this output here, it is like this. And for another cycle, this output will be like this. Okay. Now this point is 5 volts and this is 35 volts. Again, here in this input signal, this peak to peak amplitude is 30 volts. And now if you look at this output signal, again here this peak to peak amplitude is 30 volts. This is your output waveform. So this is an example of a positive clamper with positive bias voltage. Now if we consider the same situation, but if we want to analyze positive clamper with negative bias voltage, so in this case, how does your circuit look? It will look like this. It means now this diode is connected to this negative terminal of this DC battery, and we assume that it is 5 volts here. There you have VC, here you have VD, and here you have V naught. This is positive, this is negative.
And again, if your input square wave is same, that is, this is plus Vi, it is 10 volts, and this is negative Vi, which is 20 volts. So again, this diode will conduct during negative half cycle of input. So your circuit will become like this. Now this diode is short, and here we are talking about negative half cycle. So this terminal is negative, this is positive, and here we know that during negative half cycle we have 20 volts. This is V, which is 5 volts. This is negative, this is positive, and this is the direction of flow. So this terminal is positive, this is negative. This is VC, this is VD, where this terminal is positive, this is negative. And here we have V0. This is positive, this is negative. Okay. Now, again, if we apply KVL to loop 1, our equation will be start from this point plus VI minus VC minus VD minus V is equal to 0. We consider that this diode is ideal, so it is 0. Now you have this VC is equal to Vi minus V. We know that Vi is 20, V is 5, so your capacitor voltage is 15 volts. Now what about output voltage? Now we look at this second loop and apply KVL here. So our KVL equation is plus V plus Vd plus V0 is equal to 0. Here Vd is 0 because this diode is ideal, so V0 will be equal to minus V. We know that V is 5, so here V0 is equal to minus 5 volts. So what would be your output waveform during negative half cycle? It is like this. This point is minus 5. Now, what would happen during positive half cycle? This diode will be off. So again, you draw your circuit and it will look like this. Okay. Here you have V0. This is positive, negative, positive, negative, positive, negative, because here we are talking about positive half cycle, and here this Vi is 10 volts. Okay. So if we apply KVL here, we know that now current will flow in this direction. It means no current will flow through this diode. So your equation is, if we start from this point, minus Vi minus Vc plus V0 is equal to 0. Again, this capacitor will retain its voltage, so it is 15 volts during this state when diode is not conducting. So now this V0 is equal to Vi plus Vc is equal to 10 plus 20, 15, which gives us 25 volts. It means during positive half cycle the amplitude is plus 25 volts. So this is 25 volts. Now again, if you look at the peak to peak amplitude of input signal, it is 30 volts, and again if you look at this output waveform here, this peak to peak amplitude is also 30 volts. So this is an example of positive clamper with negative bias voltage. Now we will look at an example of negative clamper with positive bias voltage. Now in this case, the circuit will look like this because we know that this is the direction of diode in negative clamper, and I'm talking about positive bias voltage, so it is connected to positive terminal of this battery, and here we have resistor, and here voltage drop is V0. Here we have VC, here voltage is VD, and this is V. And again, for suppose it is 5 volts. Now if the same input square wave is applied here, where this is plus Vi, which is 10 volts, and this is negative Vi, which is minus 20 volts. So again, you will look at that part of input cycle which will forward bias this diode. We know that during negative clamper, diode is on, during positive half cycle, that is during this part. So now this circuit will look like this. Here this diode is short, and here you have V0, positive, negative. Now we are talking about positive half cycle. It means this terminal of Vi is positive, this is negative, and we know that their value is 10 volts. Now current will flow in this direction. So this terminal is positive, this is negative, this is positive, this is negative, this is Vd, this is positive, negative V, and this is Vc. Now this is loop 1. Now apply KVL here to this loop 1. Start from this point. We have minus Vi plus Vc plus Vd plus V is equal to 0. And here if we put these values, and we know that diode is ideal, so Vd is 0. Now here minus 10 plus Vc plus 5 is equal to 0. It means Vc is equal to 10 minus 5 is equal to 5 volts. Okay. Now what about V0 here? Here we look at this second loop and apply KVL. So our KVL equation is minus V minus Vd plus V0 is equal to 0, and it will give us equation like, we know that here Vd is 0 because of ideal diode, so this V0 is equal to V, it means now this output voltage is 5 volts during positive half cycle. So if you draw your output waveform, then it is like this, where during positive half cycle this output voltage is 5 volts. Okay. Now what would happen during negative half cycle of this input? During negative half cycle, this diode will be off, means it is not conducting now, and your circuit will look like this. Okay, this is positive, this is negative, this is V0, this is positive, negative, VC, this is negative, positive because here we're talking about negative half cycle, this is VI and it is 20 volts now, and positive, negative. Now again, no current will flow through this diode, so the current will directly flow towards the output in this direction. Now if we apply KVL here and we start from this point, we have plus VI plus VC plus V0 is equal to 0. Now here again this capacitor will retain its voltage, which is 5 volts. Okay, and we know that here VI is 20 volts, so now output voltage will be equal to minus VI minus VC is equal to minus 20 minus 5 is equal to minus 25 volts. So on your output waveform, you draw this like this, where this amplitude is equal to minus 25 volts during negative half cycle of input. Now again here peak to peak amplitude of this input signal is 30 volts, and again if you look at this output waveform here, this peak to peak amplitude is also 30 volts. So this is an example of negative clamper with positive bias voltage. Now we will look at an example of negative clamper with negative bias voltage. Now this circuit will look like this, where this diode is connected to negative terminal, and we know that this is the direction of diode in negative clamper. Here you have resistor, and here voltage drop across this resistor is V0, this is plus, minus, and again this DC battery is of 5 volts here. Here you have VC, here you have VD. Now again, if you have same square input, where this is plus VI and it is 10 volts, and it is minus VI and it is minus 20 volts. So again, you will start your analysis by considering that part of signal which will make this diode forward bias, which is during positive half cycle of input, means during this part. Now this circuit will look like this. Here this diode is short. Here you have V0 plus minus. Now we are talking about positive half cycle. It means this is positive, this is negative, and here we have 10 volts. This is VC and this is the direction of flow. So this terminal of VC is positive, this is negative, and this terminal of diode is positive, negative, this is VD, this is negative, this is positive, and this is V. Okay, this is loop 1. So again apply KVL to this loop 1. Start from this point. You get minus VI plus VC plus VD minus V is equal to 0. And here this diode is assumed to be ideal, so it is 0. So now VC will be VI plus V Here Vi is 10 and V is 5. It means capacitor voltage is 15 volts. Okay. Now we will find output voltage. So look at this loop 2 and apply KVL here. And now our KVL equation will be, we start from this point, plus V minus Vd plus V naught is equal to 0. And here we are assuming that this diode is ideal, so it is 0. It means this output voltage is equal to minus V, which is 5, so it is minus 5 volts. Okay. So your output waveform during positive half cycle is minus 5 volts. Okay. Now what about negative half cycle of input? So during negative half cycle, this diode is off. So now your circuit will look like this. Okay. Here you have output voltage. This is positive, negative. And here we are talking about negative half cycle. So this is negative, this is positive, this is Vi, and here we have 20 volts here. This is Vc, this terminal is positive, this is negative, this is positive. Okay. Now again, this current will flow in this direction and it will not flow through this diode. It means now current will directly flow towards the output. So if we apply KVL here and we start from this point, we get plus Vi plus Vc plus V naught is equal to 0. Again here this capacitor will hold its voltage. So it is 15 volts. And it means now this V naught is equal to minus Vi minus Vc equal to minus 20, because now we know that Vi is 20 minus 15, which is equal to minus 35 volts. Okay, it means during this negative half cycle, signal is minus 35 volts. So again here peak to peak amplitude of this input signal is 30 volts, and in this output signal this peak to peak amplitude is also 30 volts. Now for second input signal, this wave will look like this. Okay, and for third it will look like this. So this is an example of a negative clamper with negative bias voltage. That's all for today. Now what are the key takeaways of this lecture? In this lecture, you understood how diode acts as a clamper, and in this lecture you also studied about different types of clamper circuits, and you also solved examples of each type of these clamper circuits.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.